Yeah, welcome to our class, mathematics class, in our lab, a pure mathematics lab. I still remain myself, Yunusa Kazim Abiodun. The last time we met, we talked about circle geometry. In our first class, I explained the definitions of some terms, like that of circumference of a circle, diameter, radius, and so on. And we also talked about the first theorem. That first theorem is a line drawn from the center of a circle to bisect a chord, which is not in diameter, it's at right angle to the chord. I also explained it by solving the first example. Today we want to solve this problem. Before we continue, don't forget to share, don't forget to subscribe, and don't forget to like. Now let's move to today's class. Our example, the second example is a chord of a circle is 32 centimeters long. Meaning that we have a circle solution. Let me just write it like this, solution. We have a circle like this. A chord of a circle is 32 centimeters long. The chord is 32 centimeters long. 32 centimeters. The center of a circle. I've explained the meaning of a chord. That a chord is a line that is joining two circumference of a circle together without passing through the center of the circle. So we have a chord that is 32 centimeters long. The distance of the chord to the center of the circle is 12. So that means we have a chord with the distance is 12 centimeters. Distance is 12 centimeters. Now the question is, calculate the radius of the circle. Now we are going to find the radius of this circle. The radius of this circle. Radius of this circle. And how can we determine the radius? How can we determine the radius? I've explained the meaning of this thing, that a line drawn from the center of the circle will bisect a chord into two. That is why we are going to divide this chord into two. That's going to give us what? 32 over 2, which is what? 16 centimeters. Meaning that each of these is going to do what? 16 centimeters, 16 centimeters. And in the 16 centimeters, this 16 centimeters, we are looking for this. And another, that theorem is telling us that a line that is drawn from the center of the circle to bisect a chord, which is not a diameter, is at a right angle or perpendicular to the chord. That's why I can bring out this one. If I bring this one out, then I will have this to be what? This is going to be how? This is what? 16 centimeters. And this is 12 centimeters. And I've explained the meaning of a Pythagoras theorem. In a right angle triangle, a Pythagoras theorem states that in a right angle triangle, the scale of the hypotenuse is equal to the sum of the scale of the other two sides. That's why I'm going to say r squared equals to 12 squared plus 16 squared. And that will give us what? 144 plus 256. And that will give us what? 400. That's our r squared. Such that our r is equals to plus or minus square root of 400. Where our r is plus or minus 20 centimeters. Since we are measuring, we can't use negative, we can only use positive. That is why our r will now be what? Plus 20 centimeters. Meaning that the radius of this thing is 20 centimeters. 20 centimeters. 20 centimeters. That's the first solution. The second solution is calculate the length of a chord, which is 14 centimeters from the center of the circle. Okay, we have to calculate the length of another chord. Let me have the chord like this. That chord is 14 centimeters from the center of the circle. This is 14 centimeters from the center of the circle. From the center of the circle. So we are looking what? We are to calculate the length. And don't forget that with the radius of a circle, they are what? They are the same. This is also what? 20 centimeters. This is also what? 20 centimeters. Let me say this place is x. And I can bring the triangle up like this by saying this. That theorem is still telling us that this is going to go what? A perpendicular to this. This is x, and this is what? 20 centimeters. We are now looking for what? The x, and this is our r. Okay, our this is what? 14 centimeters. And I've explained that in the Pythagoras theorem, the scale of the hypotenuse, which is 20 squared, equals to x squared plus 14 squared. I can say my 20 squared minus 14 squared equals to x squared. Meaning that this is what? 400 minus, so 14 squared is going to give us 196. 196. So 400 minus 196 is going to give us what? 204. 204. So that the square root of our x our s, if it's 204 equals to what? X squared. And our x squared will now be what? 204. I can write it like this. So that s equals to what? Plus or minus square root of what? 204. So what is square root of 204? The square root of 204 is going to be around 14.28. 14.28 centimeter. 14.28 centimeter. But the question is asking us to find the length. And this is half of the length. Meaning that the length, of that chord will now be 2 times 14.28, which is going to give us what? That will give us something like around that's 28.6 centimeter. Don't forget your unit. It is very, very compulsory. It is very, very necessary. If you don't put units there, it is -1 in your head. -1. We call it wrong unit or omission of unit. In the next class, we are going to proceed to the second theorem. Like I said earlier, don't forget to like and don't forget to share. Don't forget to subscribe. Wish you best of luck in it. Thank you.